Okay, to get some extra help in Chapter 8, what you should do is go to the Tools for Success and look up all the tools there, but specifically look up the animations charts. So these are the flowcharts that are already normally in your book, but they animate them, and in some cases they give little examples where they will demonstrate something like a homework problem, but inside the flowchart. Alright, so I'm going to show you one of them. I'll show you another one right after, but I'll stick to just showing you how to identify the null and the alternative, because we're going to be identifying null and alternative hypotheses for this chapter and for later chapters, because you can often think of the hypothesis test, or you can think of the confidence interval, or there's other methods, but we like to use the hypothesis test as often as we spent all this time learning it. Alright, now here's the flowchart that's in the book, and it says to identify a specific claim or hypothesis that's going to be tested, you need to read it, right? And you're going to express this in symbols. So you take the given statement, you express it in symbolic notation, meaning use a P if you're talking about proportion, or an X bar if you're talking about sample mean, or a mu if you're talking about population mean, and so on. Sigma for standard deviation. You get the idea. And then use the appropriate less than or equal to sign, and then you're going to switch for the inverse logical opposite of that expression. You're going to switch that symbol, look at the opposite, and then you'll have your claim, you'll have it symbolically, you'll have your opposite statement, and then whichever one has the equality we identify with as the null. So here they say that you imagine a company, they make a claim, right? And that's what we test. We test claims, right? That the test preparation system will improve student SAT scores by an average of more than 200 points. Okay, so what they just said was they said that they're claiming something about the average. So we're going to use, you can watch the animations for more detail, but so because they're testing a claim about the average, we're going to use mu. We're talking about for all all students that take the SAT, obviously. So that's the population. We're going to use a sample of SAT students or people who use this program. And if that mean is supposed to be more than 200, we're going to say greater than 200. Okay, then, if that is true, what is the opposite of greater than? And don't just say less than, because you got to remember less than or equal. The number line is made up into a trichotomy, or numbers, right? You're either equal to a number, or you're less than, or you're greater than, right? So there's three parts. And if the top one is the strict inequality and doesn't contain the equal sign, the other one will. That's already getting us ready to do the next part. Okay, let's go ahead and write that out. So this is the original claim. Keep that in mind. Okay. And then this is the logical opposite, right? When the claim is not true, this would be true. Okay? Now the claim sometimes contains the equality and it sometimes doesn't. In this case, it's not containing the equality. Okay? So now we're ready to start identifying here. This then, where the equality is contained, will be the null hypothesis. We either use HN or H0 for that notation. And actually there's another notation, so I'll state the two I just said. H0, which means nothing's happened there, the null, no movement, or HN for the first letter of the word null. But sometimes you'll see this, and I like this notation actually a lot because right now H and H, they're both really vague. H0 is really vague. HN, it's got an N, so that explains, that kind of reminds you that it's null. But it doesn't tell you which parameter you're dealing with. So if you're doing a hypothesis test about the proportion, this doesn't tell it to you, right? Not this notation itself. It doesn't tell you if you were doing standard deviation, right? So there's another notation out there where we will use the parameter that you were talking about, parameter symbol, in this case mu, and I'm sorry about the handwriting there. And then we will denote it by the sub-0 or sub-n. So that would be mu sub n. Okay. All right. So the original claim did not contain the equality. Makes it the alternative statement. The other one, which did contain the equality, we only use the equality. Forget about the other part. Forget about the less than part. And then we state that as h. And that is what we test. We'll start using a mean equaling that number, whatever it happens to be, in this case 200. Every time the mean shows up in our calculation for the test statistic or the standardized test score, which is the other name for that, we'll use mu as 200. So we'll act like we know what it is. And that is how this becomes a test. If we're acting like the mean is 200 when we don't really know, when we've just used that as the null, then we're able to check and see if the null is, if we're going to reject that or fail to reject that. So if the null is going to be rejected or not rejected. And then we have to go back to our final wording to decide, did we have the null in the claim? Because if it was the claim, then depending on if we reject it or fail to reject it, we've made a decision about the claim. But if it wasn't, we have to make the decision inversely, right? I will highlight again here that the place where you see a strict greater than, like in our problem here, or if the claim happened to been, that IQ scores were less than 105, that would have been a strict less than. Or what about if they're both? If they're just not equal to something? That's essentially less than or greater than. So keep in mind, you'll either have a left tail, the way I'm listing these, it would be, you would either have a right tail, a left tail, or if it's not equal, that's going to be two tail, because if you're not equal to something, you're either less than it or you're greater than it, right? So that would be a two-tail test. In any case, anytime the statement is not containing equality, and make sure you have that. If it's a statement of differing value, then that's the alternative. So now you have two ways to think about that, two sides to the same coin.